Okay, let's start. So today's topic is about the process of organizing BIM. Okay, so basically this is a very important, let's say, strategy that we use in ISO 19650. We'll talk about IDM, MVD, and BEP, that BIM execution planning. So we'll talk about why we need this, the need for the BIM execution plans, the process, information delivery manual, IDM, okay, and model view definition and the relationship between these. So, as I have already been telling, this is not about software. It's not about using, let's say, Revit or any BIM-capable software. Okay, it's all about organizing, okay, the whole team to ensure that we will be collaborating and we will be exchanging the relevant information at every stage of the project. Okay. So in this lecture we will explore what BIM execution plan is. It's a very important document. It's a tactical document. Okay. So we basically use BIM execution plan to define the strategic goals for the project, like why we need BIM in this project, because not everyone has to use BIM. Okay. So and the expectations from BIM differs from project to project. Okay. So what are our strategic goals? What kind of organizational roles we need in this project? Okay, to be able to run BIM properly. And what are the technical procedures? Like how are we going to implement this whole process through the facilities lifecycle? Okay. Then we have information delivery manual. This is another important thing. It's a methodology where we map out business processes, okay, who's doing what, and we basically clearly define who needs what information and at what time. Okay, so this is what we need. And then we have model view definition. We will introduce again in this lecture MVDs, which are technical software filters. So some software will work with some data, and we will basically define these in the MVD. And these are basically the IDMs, information delivery manuals, are converted to model view definitions for the software. Okay, so we will talk about that. Basically, with BEP, BIM execution plan, we set the rules of the game for the whole construction team. We do this way before we sign contracts. So, like BEP is established way before the project participants are basically assigned to the project. So they are given certain requirements and they are requested a preliminary, let's say, take on the project. And then we have IDM. Again, every team works on their information delivery manuals. And then we have MVDs, like how do these work with software? Okay, so what are you going to use? I'm going to use, for instance, Revit Insights for energy analysis, or I'm going to use Autodesk Robots, okay, or ETABS for structural analysis. And what do you need for that software to run properly? Basically, we are creating a synergy. Every process, every team member works towards that. So let's start talking about BIM execution plan. It's a planning document. It's a tactical planning document. So we have the specific goals for the project, the roles in the project. Who do we have? For instance, energy analysis. Who is going to do that? we have a consultant for that, for instance, maybe. Or maybe we will say that, well, in this project, it's not a big deal. We already have a mechanical engineer, and the mechanical engineer already has experience in that. So that role is also on mechanical engineer, okay? But maybe it is a very complex project. Maybe you need very specialist energy efficiency, let's say, skills, okay? So in that regard, you might say that, well, we have a team of professors, we have a team of researchers. So the building itself is all about energy efficiency, okay? Then you have a very specialist team. They will be basically conducting these roles, okay? So you define them. And the procedures. And of course, depending on that, the client has to find these people. The client should basically prepare them, okay? So, and then the procedures. How do we run all these, okay? It's an overall vision where we have detailed implementation steps for teams, okay, in the project lifecycle. And like the architect basically creates the spaces and then delivers the spaces. But let's say you might even claim that the exterior cladding is the duty of architect. Will give you an overall vision, but the detailing, the layers, the mechanics of constructing this outer layer in a project could be the duty of facade consultants. Okay, we will have facade consultants, for instance, and they will also be working with the facade manufacturers. Okay, so we will have teams who will be constructing the facade. They are very skilled in, they know their profiles, they know their precision requirements, they know how to attach things, they know the security, all kinds of things. The scaffolding, cranes, etc. So, all participating parties are aware of the opportunities and responsibilities with BIM. So this is another thing. Like you have a facade consultant, you have an energy consultant. They should know why we are conducting BIM and what they will benefit from it and what they are requested to contribute to it. Because if you don't say that, if you don't put that into their workflows, okay, the way they work, then they will not be really making progress in terms of shifting their existing processes into a BIM process, okay? Basically, BEP, BIM Execution Plan, explains how the information management aspects of the project will be carried out, okay? So how are we going to manage the information throughout the project? So that's the idea, okay? Yeah, so the client comes with employer's information requirements, EIR, right? And the BEP details what kind of methods we will be using to provide that. So we have a project contract, and it's related to BIM execution plan. This BIM execution plan is actually a contract, but it has all kinds of definitions. Like, as I said, we have structural analysis team, okay? We have structural design team, maybe we have a separate energy consultant, okay? Maybe we have different roles for different purposes. So we have roles and we have data exchange protocols, okay? So we have responsible people, we have different software that will be used, and there will be requirements in terms of the LOD. Maybe we'll use different versions of software. So that's what it is about. Basically, it's a 4-step planning procedure. We identify the BIM goals, then we design how the BIM will be executed, okay? The design execution process. Then we develop we define information exchange. This is the wrong order. Then we develop supporting infrastructure. Okay, so who is going to give whom what kind of information, and to be able to create that, what kind of supporting infrastructure do we need? Like we need Revit software, we need these computers, we need scanners on site. There are all kinds of things that you can think of. Okay. So that's the idea. Basically, that's the BEP prior to project, we have pre-contract BEP. Then, like, it's given to the members, they basically work on it. Then after the contract, it is updated, and when it's necessary, it gets updated, because through the project, you may need to do that, okay? So why can't we just work like with BIM? The issue is that if we don't do that, we may over-design, we may do many things in advance, which will not be used, or which will be problematic, okay? So we want to go step by step. So during the whole process, so this means that the whole architectural design process is also, well, whole building design process. I'm not going to say architectural design process because we have many different, layers. So they're all organized, they're all planned at the beginning. So we will tell the architect, for instance, you will come up with this level of information at this stage. Don't go further, okay? You will prepare that. Basically, the thing is that if we don't do that, we will be wasting money. So if we have a well-documented plan, okay, in that regard, basically the scope of BIM implementation is defined clearly, okay, and that basically allows us to have a process flow. And we will say, architect, you will design that, and then you will give it to structural engineers so that they can, let's say, they can make sure that the beam depths are perfect. Okay, so they're perfect. So, and then you take it back, you organize the spaces again, then you give it to the mechanical engineer. The mechanical engineer will then look into the need for space underneath the structure for heating, ventilating, and air conditioning. Okay, so because what do you have? You have the floor. You may have raised floor. Underneath the raised floor, you have you have pipes, you have cables, you have data, electricity. Then you have finished floor. You have suspended ceiling. On the suspended ceiling, you can see the lighting fixtures. You can see the fire protection, sensors, cameras, everything. Behind it, you see fire suppression, the pipes. Behind it, you have the electricity lines. Behind it, you have ventilation, air ducts. Behind it, you have the structure. The one go. Okay, so basically, you prepare your process so that all these are sized, planned accordingly in time. Okay, so for the complex projects. Okay. Otherwise, I mean, we can all use Revit, we can all work on it, but at the end, it's going to be a complex model which will not be useful to anyone. Okay. So instead, we will be working together, putting things together in time. Okay. It is like 3-4 kids are playing together with Lego. Okay. When you play Lego with your friends, if everyone is like doing things by themselves, it doesn't fit. But if you are like following, and if one person is proposing things and asking the others, like, I need now the block of 4, block of 6, 8, then you basically follow the whole process and create something that is that's perfect as an outcome. Okay, so I play Legos a lot with my daughter. I used to, and my in Nepal now. Right. So basically, we have 4 steps. Okay. So what are the high value BIM users? Okay. In the project design, planning, design, construction, operational phases. So what are the high value BIM users? Like, why are we going to use BIM? Like for energy planning, for material. Maybe it's a very critical site. Maybe we really need it for the operation phase. Okay, so what do we need BIM for? Then we create detailed process maps. What kind of tasks do we have? And what kind of models do we need for these tasks? Okay. Then we define exact BIM deliverables in terms of structured information exchanges. Like we will say that, well, at this stage we are expecting from the architect an LOD 100 model, a very simple model. Okay, of which will have spaces defined, Okay, this is the lecture hall, this is the corridor, this is the living room, this is the boundaries of the structure. These are like simple walls, okay? They're simple walls, basic walls, okay? And that's how resources. Then also, we developed the supporting infrastructure. Now, in this case, we want to claim that, we want to say that, well, we need this software to be able to run, and we are expecting our project to be this many square meters, so we will test that for this many square meters, you need this much of RAM in your PCs, this kind of processor you need very high powered, high speed networking, maybe high storage capacity, maybe central storage. And then another thing that we will say is that what kind of quality control we need for the models. Like architect will submit the model, but someone should check if it includes, for instance, highly detailed parts when it doesn't need. Okay, so then they will respond to that. Well, you're not doing right. Okay, etc. So yeah, high value goals. Design. We redesign the execution process map. Okay. Then we define the data standardization, standardized information exchange protocols. Then the computer network, the computers, the processors, graphic processors, etc. Okay, the cloud, like what kind of cloud you will be using? Okay, your own company cloud or an Amazon service, what is it? Or a commercial service. For instance, this is important because your high-value BIM goal is to keep the BIM process within the private network of the whole. This could be a goal too, like private. It should be all private. You don't want it to be released to internet. You don't want it to be hacked by a rogue government. Okay. So there are many bad actors in the world now, okay? In the West, in the East, and these bad actors could be targeting your building. And your building could be a very critical building. Okay, I mean, if you're building for Ministry of Defense, it's a critical building. Okay? If you're building if you're building a nuclear power station, it's a very critical building. You don't want anyone to have any knowledge of its workings. How does it work? Because if they do, they know what parts in the building are critical, and they could target it. Because it's something that you want to know. Yeah. Then, of course, you begin with the end in mind. This is another important thing. Why do we use BIM? Because we want the BIM to be useful throughout the life cycle. Okay. So you want to you want to make sure that your team members, okay, in the BIM process, your team members understand what are the uses, the future downstream use of the information they are creating. So, mechanical engineer is creating the pipes, okay. Well, they are only interested in the construction maybe, okay, but they should know that the facilities managers, after 50 years, would like to know how to replace these pipes. Okay, so they should be preparing these, maybe even they should be designing these with that in mind. Why do we have these pipes? Did you know? Because the original pipe, when I was a student, we didn't have these pipes. So these are relatively new. These are 20 years old, or 30 years old, sorry. So, relatively new. That was a good one. The original pipes are going through underneath the floor. Okay? So, they had two choices. They couldn't, and the pipes were all blocked because of calcium buildup. Okay, when I was a student, it was terribly cold here. The glazing was single glazed, and there were no pipes like these, so the radiators were mildly warm, right? They were never hot, so we were always cold. And to be able to fix that, they couldn't remove the pipes. So that was a problem on the engineer side. They didn't design it in a way that the pipes could be replaced without damaging the rest of the building. What rest? The flooring. The flooring of the building is very special. In many areas, we have beautiful, let's say, terrazzo tiles. We have beautiful, you cannot find replacements. Even if you find replacements, they will never look the same. Okay? So you don't want to break that floor to replace, and that's what they invented. But if you ask if I was managing the project, what I would do? Well, I would put all these pipes on the roof and bring them down as lines from the roof. So maybe one day I'll be the dean and I'll replace the whole thing, and it's going to happen. Then these are the two. This is the second thing that I want to do. The first one is I'm going to plaster the walls, so have a good paint and all that. No, that was what. Like when I got the job as an assistant here, like 25 years ago. Okay, I was telling my friends, my first job will be finding the right person to do the plastering of the building. So anyway, I'm kidding, of course. This is a Britain's concrete building. You never do that. Right. Yeah, next week I'm getting a plaquette from the rector for my 25th year at the university. Good. Yeah, operation phase of. The thing is that we want to know what the information will be used, okay, in the future, and what can we do there. In that regard, for instance, facilities managers, they should be coming to the project in advance, okay, to tell us what they want, what they need. Okay, so like I want the maintenance to be easily done. I want the things to be replaceable. I want a database of things that you're using. I want a database of the pipes, the sections, etc. So if you identify these, then of course you focus on reusable project information, which means that at many different stages, the information that you create will be reused. Okay. So facilities manager is all about defining the goal. Okay. So they basically define the information that they need. Construction people are looking into the BIM model as a virtual prototype, so they also require information from the model, okay? And the architects, they design this whole information file. Okay, so basically they make sure that whatever they do helps these people, okay? Construction people, procurement people, like it could be very near future, it could be very far future. So you define that, okay? So BEP is a living collaborative document in that regard, okay? So it's not static, okay, and it's continuously updated so that we make things better. Because even though you set the rules at the beginning, sometimes you figure out that there were things that you missed, there were things that you could have done better, okay? So you need to nurture that culture of change, if necessary. So basically, we stimulate planning and direct communication among every people. So we develop at early stages, but we monitor, update, and revise it as new people join, as we figure out there's something wrong or needs to be changed. And this also gives us a benchmark for progress, okay? And also this helps us to understand how our collaborative process is working, okay? Yeah, so we have the BEP version 1. It starts, but like we define the roles, we have one plan, but then as we continue, we have dynamic living roadmap in the project. We basically sync the federated model, we standardize data exchanges, but it continuously gets updated. So now we're talking about information delivery manual idea. Why do we need that? Well, IDM is an international standard methodology. So for any process, we basically map out, we basically formally define the exact flow of information. ISO 29481 is the code, standard code for that. IDM basically unites the flow of construction process with the specific digital information required to execute. So, for instance, basically it tells what information is needed by whom, at what point, and in what format. Okay. For instance, if we are defining the role of structural design, okay, structural designer needs to know the overall volume of that space, the support or supporting elements that is proposed by the architect. So architect will say, well, I think we can have some columns here, but I don't know how many we will need. I don't know how, let's say, how they should be sized. I think we will have some beams, but I don't know. I just want an empty 11 meter by 22 meter large space, okay? And I want a courtyard next to it, so the architect is providing it. Then we will also say that, well, there will be about 70 students. The maximum they can do is dense, there is not much they can do. We will have tables, we will have models, okay? So these are the dead weights and live weights. We will have flooring, we will have roof, etc. So like you all define these. So the structural engineer receives that information. So this is the information that the structural engineer needs, and then they basically set their software so that it calculates the need for reinforcement, let's say, in the floor. Okay, so and then they propose. Well, we can have beams crossing like that, or we can have a structural system that's made of waffle slabs like that, okay? Or we can convert it to a steel structural system. We can have a steel floor, but architect will also say that, well, I don't want vibration in the building. No. Okay, so like if you jump up and down upstairs, it's not going to vibrate a lot. Okay, here this building in that regard is very solid. But if it was a steel building, it wouldn't be so. Okay? So, yeah, what information? This information. Who? Structural engineer. And when? Well, when they start working on the structure. Okay? And in what format? Well, in that regard, architect could say that, well, we will provide you as a Revit file. Okay? Or an IFC file that's exported through Revit. Okay? Whichever they prefer. Sometimes, some projects, they say that the exchange will be strictly on IFC. Very simple, let's say, representations, IFC. And of course, different disciplines basically reach comparable stage of design work in that regard. Similarly, for instance, mechanical engineer. What do they need? They need to know the space size, the volume, the glazing that is proposed, the heating and the location of the site, of course, the glazing types, etc. And accordingly, they will run energy analysis and they will say that you need heating fan coils at every window. But then you are, as an architect, you say that, well, I don't want to put them in front of the windows. I want them between the windows, right? This is how it is done, right? Why? Because I want the windows to be from floor to ceiling, perfectly, lighting up the space. So then, of course, the mechanical engineer will request the files from you, and then you will give them, and then they will use them to do their analysis. So every team member gives a piece of information, and the other person basically does what they need to do. Okay, so this whole exchange is clearly defined. Okay. So IDM in that regard is a translator. Now, what does it translate? Basically, a structural engineer, okay, does things in their own way, okay, or a mechanical engineer has his or her own way of working. Okay. But with IDM, we basically describe what they need from other people to do what they need to do. Okay. For instance, if it is a facade designer will require, for instance, where our floor levels are, what kind of openings we need, what kind of height we are working with, the wind, the location, the expectation from internal, let's say, users, etc. And the facade designer will propose ideas. Okay. So basically, this way, the facade designer defines what they need, an architect defines what they can give, and then we define what the software should do to take from the architect and give to the facade designer. So that's the idea. Okay, the software basically is the intermediary thing. And we use different software. But of course, with BIM, we try to stick to a simple exchange protocol, simple creation process of the whole model. And exchange something that is interoperable, like something that we can exchange easily between each other. Okay, so that's the idea. So, basically, this also, for the software developers, it also provides a clear functional breakdown of information exchange requirements. Like, you need to deliver an IFC model with about spaces, an IFC model about structure, etc. Okay, and with the if we have the business processes written in IDM, then architect, the software engineers, software designers, or our teams who are basically. Another thing is that, let me tell you about that. Now, in big projects or big companies, they, in the construction sector, they also have software engineers. So, like, as a company, you don't just go and buy software. You write your own software. So, because you can write additions to Revit, you can write add-ons to Graphisoft, BIM. They have their own teams who write the add-ons. It's their proprietary, even secret software. They don't share with anyone else. Okay? So if you're a big company, you have your own software, let's say teams, that basically write your own software. So if you are interested in software, if you're interested in these fields, this is also another opportunity, because this will never end. There will be always someone, even if it is done with AI, there will be always someone who defines what is needed, what should be done, etc. And you can find great job opportunities in that regard. Okay, yeah, the architect defines the intent. We have the one model. We have the information that's shared between each other, and also we have solution provider who writes the APIs, okay, for these projects. So BIM is this process, but in the process we need to define everything so well that it can be turned into a software too. Okay. So there are three core elements for IDM. Okay. Building Smart, if you remember, Building Smart is the organization who basically defines all these things. They mention for the IDM, they mention use case, process definition, and exchange requirements. Use case, for instance, automated cost estimating. Okay, so you want to be able to estimate the project quickly. For that, what kind of how the use case will be developed? Use case will work. Okay, will be executed. Like you say that, well, for instance, automated cost estimate. We first need to know the numbers for the volumes of material, and then we can define that. Well, for services we use, we need to calculate, including this and this and that. For the volumes, we need to only count the walls, infills. For the material, for structure, we need to look into the weights, for instance, etc. And this needs to be defined, the process. Okay. Then exchange requirements. Then the question is, like, what do we need from the structural engineer to be able to calculate the amount of steel we need for the project, the amount of concrete we need for the project, or the amount of scaffolding we need for the design. Okay? So, yeah, the use case, you define, like, what is it? Structural design, energy analysis, bit of quantities. Okay, what is it? Then, how do we do that? Well, you do this, then you calculate them, you then list them, you multiply them, you put them together. And what do you need for that? For that, you need number of walls, number of columns, number of beams, etc. You should be able to list those, okay, and so on. So that's the exchange requirements. And then we have, of course, process mapping. We have this thing called business process modeling notation. So we create actors, we create roles, okay? We basically, we create a process map where we outline step-by-step activities for the team, okay? So here, architect basically generates the 3D geometry and then simplifies the model. Now you cannot tell the architect to create a simple geometry just for the sake of energy consultant. You tell them you create this detailed 3D geometry, but you simplify it if you want to give it to the energy consultant. Okay, you don't give the project with all the windows, doors, etc. to the energy consultant. You give them as if you remember from last week, for the analysis, we have an analytical model that we give. Okay, simple model. So you define what the data exchanges. It could be IFC, okay, or it could be GBXML, okay, and then consultant. The consultant does the iterative design feedback. So architect does something, sends to the consultant, runs energy analysis, then sends it back to the architect. So there is this exchange between the architect and the energy consultant continuously so that the project is reducing its energy requirements. Okay, so that's the idea. And the exchange requirements, ER, basically we define what is required for the data in that exchange, okay? Because we don't want to deliver too much information. That's data bloating. The bloated data makes things work difficult, okay? So we want to receive reliable, actionable data. We don't want uncoordinated, messy model, okay? So we are trying to inhibit wooliness and weightless of data. So we don't want all these chairs, tables, beautiful, Porsche cars, etc. in our models. We want very simple models. Because we need to, it could be that. See, remember, I was always talking about this complex thing as like drawings, etc. Now we are talking about the model. Model, like if you don't do it right, you can also have garbage models too, okay? I mean, just because we can model doesn't mean that we should model everything at every stage. Okay, so we have to be very careful in that regard. So, a massive 3D model is very difficult, so we need to filter it based on exchange requirements. As a result, we will receive the relevant data as each team. So, let's talk about model view definition. Basically, when you export this data, it's very difficult for the software to deal with, okay? So we use, and when you think of IFC, IFC is covering a lot of things, okay? So you don't want to deliver everything that IFC tells you that you can deliver, okay? So, so the data dump is what we are trying to avoid. So if we want to achieve true interoperability, okay, we want to do task-related exchanges. What is needed for that task? And we exchange only that, okay? So we don't just click IFC export button, okay? So we export only the things that are necessary. Because if we dump the data to everyone, the computers will run hot, they will slow down, things will be slow, okay? But you want to filter and send the necessary things, and we use MVDs to filter this noise. Okay, so what is an MVD? MVD is a technical filter in that regard. Okay, it translates these human readable exchange requirements into computer readable subset of the IFC database. Okay, so IDM, which we talked about in the previous part, is translated into a technical format, which is MVD, okay, model view definition. And here, we use, but the thing is that MVD is not something exactly we do or we design. It comes with the software. Okay, so you have your IFC schema, very complex, but the software basically creates what is needed. So this is what we call, for instance, coordination view. Okay, only for general exchange and special coordination of models. So you exchange some simple view. Okay, or you give structural analysis view. Remember, I was showing you last week the structural analysis model. That's what you do. So there are standard filters for many different things, like quote takeoff, scheduling, FM, handover, like Kobe, etc. Okay, so this is integrated into the software. And also, as I mentioned, your company may be too big, you may have too many processes ongoing, you may have your own software engineers who prepares MVDs for different software for you to use. Okay, so that's possible. So it is something that really we don't directly deal with. Okay, it comes with the software that we use, for instance. But we need to be able to provide that MVD for different software from our own software. Okay, so when necessary, we give complex models. But when necessary, like in certain cases, but when necessary, we give one very simple one. Okay, so MVD defines that. And in that regard, we have something called software certification. Again, Building Smart certifies different software for their capabilities in that regard, where, you know, if the platform is able to implement that, MVDs, okay? And basically, advanced users also can use MVD XML to create their custom MVDs and see how the IFC file can be validated for the requirements that are defined with IVD. Okay? Yeah. So this is the idea. Basically, we want to. This is also, Vim validation is also integrated into the VEP. It's like you have teams doing that. We want to know what people send is useful for the other parties. Okay, so it's adaptable to their software. So what's the relationship between VEP, IDM, and MVD? So we want to have this interconnected thing. So we have to have project-specific rules with like VEP. Then we have standardized human processes, information delivery manuals, IDMs. Okay, so we know what we need to do for whom, etc. Right? Then we have the technical software filters. Like to be able to do that, we know that we need to, for instance, give these people that particular model with these information pieces integrated. Okay? So basically, we don't hit a generic export button. We use different exports for different needs. So in that case, for instance, if you're using Revit, okay, it's at one stage if you need to export the model for instance, facade people, okay, the facade consultants, then you basically you define what facade designers need. You create a filter, export filter, and then you export it for them. Okay, so what you export basically works for them. Okay? And information delivery manual basically provides a methodology to define human workflow. Like we will say that the facade designer will receive from the architect the openings, the structural system boundaries, how the surface changes in the building, and then they will work on it accordingly. Okay? And the MVD is the technical translation, and then we will say that now for that, architects should use their model, convert it to an IFC model, with these filters so that the facade designer receives only the outer scale, not interior partitions maybe, not the ceilings, or maybe they need the ceilings, but not the doors inside, etc. Okay, so they don't want that. Yeah, so we have BEP, establishing the project rules. We have IDM, we map the information flow. We basically we do the process map and we create requirements. And then we have MBD, software export filter. So how our software exports file accordingly. BIM is all about creating information, receiving information, using that, creating information, then giving more information to the people. And in that case, this export process is defined by these gears. Okay? And with the BEP, we of course define appropriate BIM users. Now in this case, like why do we need BIM? Maybe we don't need it for energy. Maybe it's just a building that's open to the outside, so we don't need any energy requirements. Okay? Maybe it is a building that is technically open, technically, let's say, not controlled in terms of climate. It's a maybe warehouse. Okay? But you define that we don't need energy efficiency, let's say, use case for the project. But you need, for instance, space efficiency. Okay, that's a new one, for instance. And also, we outline the implementation details of the project. So BEP is a living document, right? So we have the shared tactical execution contract between every team member. Okay. And IDM, in parallel, it uses the standardized method for creating how the processes will be defined. Okay. Basically, everyone is working on their own task, and we define what their task is and what they need from each person. So, when you think of it, it is a basically overall management, let's say, plan for the whole project, from the very beginning till the demolition, operation included for 50 years. Okay, so we need to define everything. We need to be able to say that facilities management, facilities management, after 20 years, after 10 years, facilities management will need to replace all the toilets because they will be worn down. So they will all knock down, they will put new ones. Okay? Then the question is, what needs to be kept, what needs to be replaced? Do we want to replace all the piping? Do we just want to replace, do we want to keep the plans, like where the toilet walls are, where the sinks are, like do we want to keep the toilet as it is? Another example, the toilets that we have, student toilets, it wasn't like that before. When I was a student, we have a very completely different layout. Now it's something else. This was done like 20 years ago. So when you think of that, the question is, what do we want to present them? Like, do we want to give them do we want to make sure that the pipes that are feeding the whole structure are defined clearly and they can be, we also define how they will be replaced if needed, okay? Do we want to show them where other things are? Like all these things. This is a 50 years, 60 years projection into the future. So we are basically preparing for that. Then of course, MBD, the technical software filter, for every task, we want to know what we want to export, how we want to export, what kind of data granularity that we need. Okay? Yeah, so it's a filter, because we have this whole complex model, but all we need is this thing. Okay? And we have mini IADM workflows in BEP. So basically, we make sure that we have a similar logic of mapping, okay, and to create the BEP itself. And also, during that, we also make sure that the MVD is known by everyone in the project. Okay? Yeah, so this is how it works. Let's summarize and finish this week. Basically, just because we say that we will do BIM doesn't mean that we'll be exchanging information, data, immediately, quickly, and as required, okay? So we need a strategic planning of the BEP, okay? We need to clearly map the processes via IDM, okay? And also we need to precisely technically filter the data that we generate with MVDs, okay? BIM execution plan is the foundational tactical rule book. So we basically define the rules for each team. Okay, project goals, specific BIM users, organizational roles, how do we collaborate? So we do that. Information delivery manual, IDM, standardizes the workflows of each team. Like the way it works is, I'll give you one example. In one project that I'm consulting, okay, the authority, if we get this, they didn't get the job yet because it's not announced, but if they get the job, it's going to be a big one. And I'll tell you then, but now we are really praying, hoping it's going to happen. If it happens, it's going to be great. But it's going to be one of the biggest jobs in the world, okay? And if you can get it, it's going to be good. But the idea is that they have 1,700 pages of documentation. The clients, what their information requirements, employers' information requirements, their BIM execution plan or drafts, right? There are all kinds of things. And they asked this team that we are consulting, okay, they're giving consultancy service to. They asked them, for instance, how are you going to design what you're doing? What is your process? So they didn't even get the job. But before getting the job, this team is doing structures. So they are asking this team how they are designing the structures, how they are going to manufacture it, how they are going to transfer it, how they are going to put it in place, like all their processes. And what kind of information process they have within it. So they have to define that, okay? And these people, they had to read 1,700 pages of document, or they had to basically go through and figure out which parts are important for them. Because this is going to be a huge project if it starts, okay? And the project owner, the client, wants to know that this team will be able to fit, okay? Because they will prepare the information delivery manual for them. Because they will say that, well, for this team, we need to, this team needs, the client has the design. But the design itself, the preliminary design is finished. I mean, this project has the preliminary design already finished. Now the final design needs to be done. Okay, like the structure, how it's going to be there, like what kind of materials they're using, how are they going to put it together. And all that still needs a lot of preparation. Okay, so IDM, they want their take on IDM. And also MVDs, like they were asking, what kind of software do you use? Do you export to IFC? How big your portions will be? How do you break down the whole structure? How many meters you are going to break down? Because you cannot, otherwise you cannot, how do you say, maybe analyze it. Okay, the computer will not be able to build it. So that's what it is. Accordingly, if the client thinks that this company, this is a construction company. If the client thinks that this construction company is capable of doing that, then they will sign a contract with them. They will give them the job, okay? And when they take the job, then they start the BEP again with the company. So this preliminary stuff is, but they only propose their own take on BEP. Okay, and then at the end, the whole project will have their own BEP. The whole project will have its own information delivery manuals. And for the whole task of information exchange, the model view definitions will be described. Okay, so that's the idea. Then project starts. So when you think of it, we do a lot of planning before we start doing BIM. We don't just jump onto Revit and start modeling. It doesn't work that way. Okay? Or this is the thing. If you go to an office and if they tell you that they are doing BIM, but they're only using Revit, you can kind of tell them, okay, don't challenge people, right? So it's very, yeah, no, don't do that. Be nice. Okay, so okay, very nice. Oh, but so tell them, have you heard about ISO 19650? And if they say no, well, maybe you should check it out. It's very interesting. You'll find it very interesting. And then they will figure out that they are not doing things. Okay? Because using Revit is not good. Revit is just a software. Using Revit is just using Revit. You are using Revit. Are you doing BIM? No. I mean, this is just a studio. You're not even designing actual buildings. And that will be constructed. But, you know, you're using Revit as a student. Who will stop you? I mean, I'll tell you not to do that, but you will do it anyway. Good, yeah. This is the important part of the thing. So today, in the tutorial, we have mechanical, electrical, and plumbing. So you'll do piping. You'll connect what you will do is you will enrich your architectural model by creating a bathroom. I am giving you some objects in AutoClass. You can download them. You can load them into a new project. You can load them into your existing project. You know you have a firehouse project, so you'll continue with that. You'll create a bathroom in a specific area of your wish. You need to put showers, toilet bowls, sinks. Each one has wastewater, cold water, hot water connection. And you will create pipes to connect all these, okay? And it's up to you. You'll figure out how to do it. But the thing is that the tutorial I cannot make it like 2 hours long. So in 1 hour I'm showing you how to connect pipes and how to do things, etc. And that's it. So you will learn from there and then do many pipes if possible. Okay? It's fun. It's a bit cringy. Like it's not really, sometimes it doesn't work as it should. You will see in my exercise I also stumble on things, but you will figure out. It's fun. So you'll be a mechanical engineer today, an electrical engineer.
Yay.
Okay? Good. Any questions? Okay. I will save this one and see you next week.